Objective. The purpose of this assignment is to calculate the convolution operation to describe the response of an LTI system and the use of MATLAB to plot the result of this operation. In this assignment, students will analytically evaluate and verify the result using MATLAB. Methodology. MATLAB, generating signal. MATLAB provides a wide variety of functions to accommodate all the functions exist in the mathematics. Especially in our regard is the rect, heaviside, for you, and much more. Since we want the symbolic representation of the resulting convoluted signal, we solve it by using SIMS keywords. Representation of signal. MATLAB does not only offer function library for us to solve mathematical equation, but also a graphic library for us to plot the original signal and the convoluted signal using fplot. If fplotting symbolic function x label, y label, and title to add useful information to the plotting and subplot to combine all plotting in the figure. Operation of signal. By using the convolution theorem, the operation involved are the multiplication of two signals with one remains stationary and another one is swept through the time domain, and the second operation is the integral of the multiplication of two signals earlier through the entire time domain from negative infinity to infinity. Methodology for convolution. Convolution is a mathematical operation on two input functions to produce a third function. To perform convolution, one signal will be chosen to be inverted and shifted by t. After that, the area of intersection between two signals is calculated in each interval, as explained in this presentation. Methodology for Fourier transform. The Fourier transform is also used when convoluting two functions due to the property where f omega g omega, as explained in this presentation. Methodology for Laplace transform. The Laplace transform can be seen as a more general form of the Fourier transform due to its ability to decompose a function into the constituent sinusoid exponential, where sigma represents the exponential part of the signal and I omega represent the sinusoid of frequency. This is seen in the situation where sigma equal to 0, which result in the equation assuming the integral converges, as shown in this slide presentation.
So, kita pergi ke calculation. So, kita diberi xt sama dengan 2ut tolak 1 tolak 2ut tolak 2. So, kita guna definition untuk ut. So, sebelum dia pergi, sebelum t sama dengan 1, dia akan kosong. And then bila t lebih daripada 1, dia akan naik ke nilai 2. And then untuk negatif 2ut tolak 2, dia akan kosong sebelum t tolak 2. And then dia akan turunkan negatif 2 bila t lebih daripada 2. So signal dia akan jadi bentuk rectangular macam ni lah. Dia naik dekat t sama dengan 1, and then dia turun balik dekat t sama dengan 2. And then kita punya rt pula, rt sama dengan 2 tolak t ut tambah t tolak 2 ut tolak 2. So untuk ut t tolak 2 ni kita kena kembangkan, and then kita akan dapat yang bentuk dia akan naik dekat 2, sebab kita akan kembangkan ni, kita akan dapat 2 ut which is akan naik dekat 2, and then negative t ut dia akan turun dekat sini lah. And then kita akan ada ramp t tolak 2 ut tolak 2. So ini ramp function lah, ramp function di mana dia akan naik sebanyak keturunan sebanyak 1, and then dia start dengan part pintasan Y dia dekat negatif 2. So sebab bila kita tengok ada clashing dengan dua function, so kita ambil average dua function tu, dia akan jadi mendatang dekat bahagian ni. So kita dapat RT kita macam ni. So then kita punya conclusion dekat sini. So XT convolution RT sama dengan integration of R tau darab X T tolak tau D tau daripada negatif infinity ke infinity. So dekat dalam calculation ni saya ambil XT untuk switch to time domain. So saya tukar dia punya dalam ni dia akan jadi T tolak tau. So daripada 1, 2 dia akan terbalik ke negatif 2, negatif 1. And then saya shift dia by T, and then dia akan jadi ni lah, T tolak 2, T tolak 1 dekat sini, dekat belah negatif T. So let's say saya ambil saya letkan YT sama dengan XT hasil convolution XT RT. So kita tengok bila T kurang daripada 1, kita ambil yang ni, sebab bila T tolak 1 kurang daripada 0, kita akan dapat julat masa T kurang daripada 1. So bila T kurang daripada 1, kita akan nampak yang YT kita kosong, sebab dia tak ada overlap lagi dekat belah sini. So bila masuk dekat antara 1 dengan 2, kita akan nampak dia ada overlap dekat antara kosong hingga T tolak 1. So maknanya kita punya integration dia akan berada dekat situ, limit integration dia dekat situ. So daripada kosong ke T tolak 1. So kita tengok kalau dekat belah sini kita cuma ada luas dekat bawah ni je, yang garisan menurun ni. So garisan menurun tu kita tahu tadi T tolak 2, tau tolak 2, sebab daripada atas ni, daripada yang atas ni. So kita integrate, kita akan dapat negatif T squared tambah 6T tolak 5. So kita dah dapat untuk julat masa yang ni. Kita pergi ke julat masa antara 2 hingga 3. So sekarang julat masa dia bukan lagi dekat kosong, tapi antara T tolak 1 dan T tolak 2. Sebab kita dah melepasi X, Y sama kosong, X sama kosong. So kita punya limit dia dekat T tolak 1 dengan T tolak 2. So limit dia dekat situ. Dia punya area of integration pun tetap sama dekat negatif T, negatif tau tambah 2, sebab dia masih dekat garisan menurun ni. So kita buat integration, kita akan dapat negatif 2T tambah 7. And then antara 3 dengan 4, dia punya limit akan jadi dekat sini pula, antara 2 hingga T tolak 2. Sebab dekat T tolak 1 ni dah tak ada function yang overlap, cuma tinggal XT je. So kita guna limit daripada T tolak 2 hingga 2. So dia punya area of integration pun negatif tau tambah 2 juga, tak berubah. And then bila T lebih daripada 4, kita dah tak ada apa-apa lah, sebab kita dah keluar daripada signal RT tu. So conclusionnya XT convolution dengan RT, kita akan dapat piecewise function, yang mana bila T kurang daripada 1, kita akan dapat kosong. Antara T antara 1 hingga 2, kita akan dapat negatif T squared tambah 6T tolak 5. And then antara 2 hingga 3, kita akan dapat negatif 2T tambah 7. Antara 3 hingga 4, kita akan dapat T kuasa 2 tolak 8T tambah 16. And bila T lebih daripada 4, dia akan jadi kosong balik. So itu saja daripada saya.
Hi, my name is Yazid, and in this video I'm gonna show to you the coding that we have done in MATLAB. Okay, so this is the MATLAB interface provided with the coding that we have been made, and it's total 40 lines including comments. Okay, let me go through line by line. The first one, we use the sims function to declare the symbolic variables to define the signal, which is in this case we use t, u and v. Okay, and the second one is we define the signal xt and rt, which have been provided by us through this equation. Okay, the xt and the rt, we use the heaviside function because in MATLAB for the unit step function is declared as heaviside. Okay, for xt is 2 heaviside t minus 1 minus 2 heaviside t minus 2. For the rt is 2 minus t heaviside t plus t minus 2 heaviside t minus 2. Okay, that's the two equation provided to us. And then we define the resultant signal, which is h omega of the convolution xt and rt. So it became like this: h omega equal to integration of xu times with rt minus u, and is with respect to u, the limit is negative infinity to infinity. Okay, so that's the equation, but we add up some more. The equivalent resultant signal of the convolution xt and rt by equation that have been done by hand calculation. So this is the equation. Okay, just to compare from the programming side and also the hand calculation side. Okay, then to show the results, you need to create the plots of the signal source and the convoluted signal. Okay, the first one is the signal xt. Okay, so we use the subplot, fourth row, column, one column, and is in the first place, which is on the top, most top. And plot the xt. The limits is from -1 to 4. Okay, so this is the x label, time in second. Y label is the magnitude. Okay, this is the title of the plot, signal xt. And then for the middle one is the rt signal. Okay, same. The position is the second one, the second top. Okay, and then plot the rt from -1 to 4. And then the x label and y label is the same. So only the title where we change to the signal rt corresponds to the signal that we want to plot. Okay, for the bottom is the h omega. This one is in the third row. Okay, the x label we use the angular frequency, which is in omega, symbol omega. Y label is magnitude, and the title for this plot is signal h omega. Okay, we plot it as the same. H omega is between from -1 to 4. And then for the last one is the g omega. It is from the hand calculation. Is on the bottom, most bottom row. And with the f subplot, fourth row, and then f plot g omega from -1 to 4. Okay, the x label and y label is the same for h omega, and the title is signal g omega. Okay, so let me run the coding. Alright, so it may need take some moment for the MATLAB to process it out. Okay, so now we have seen the signal produced. So this is the signal xt, signal rt, signal h omega, and also let me maximize to give a clearer view. This signal h omega and g omega. Okay, So this is the result that we have gotten. If we can see here, from the H omega and G omega is the same. So in analysis part, Miss Gangesh will explain furthermore the comparison of between the hand calculation and also the programming side. Okay, that's all from me. Thank you.
Hi, my name is Gangesh. I will be going through the analysis, the comparison for the manual calculation versus the MATLAB calculation. So as what our previous group member have shown is the calculation method, how we obtained the graphs, and also another team member have explained the MATLAB's coding, source codes, whereby we also have obtained similar version of graph. So here is a mere comparison. So this is manual calculation of how we did the convolution, and the graphs is square, wave, and a triangular. So as you can see, we have also found the YT, and the final value is this. So this is what we obtain in the MATLAB calculation. So signal XT, RT, HW, and G omega. So if you can compare here RT, and XT, so the graphs are almost similar. So also we have used decimals, somewhat it is similar as well. So as a conclusion, convolution is a mathematical tool to combine two signals to form a third signal which relates the input signal and the impulse response of the system. This is to produce the output signal from the system. The term convolution refers to both result function and the process of computing it. Hence, the convolution theorem can be used beneficially in many applications that include probability, statistics, acoustics, spectroscopy, and so on. This is very much applicable for engineering, physics, and computer vision, and also differential equations. Generalizations of convolution also have applications in the field of numerical analysis and numerical linear algebra, and in the design of implementation of finite impulse response filters in signal processing. So, in conclusion of our MATLAB assignment, the operation of convolution in frequency domain matches the operation of the convolution in the time domain for two linear time invariant functions. The use of software such as MATLAB can be which will be allow us to use as engineers to perform signal analysis and automate a lot of process. So that's the end of our video here. Thank you for watching.